This is a GCSE video on electric circuits. Now, you've seen this briefly in the previous videos, but the first thing that you need to know about circuits is how to draw them on paper. Now, we always draw wires as straight lines, and remember, the electrons have to flow in a complete circuit. They need to go all the way around, so one end has to connect back to the other end in a circle, or the circuit will not work. Now, the ones that we saw last time are the cell. Now, a cell is an individual power source like this. And there's a big line of the little small line, and big line is the positive one, small line is the negative one. Now, the other thing that we saw last time is this, which is a resistor. Simple resistor, just a rectangle like that. Now, last time in the video, we saw that electrons flow around the circuit. Now, electrons are negatively charged, but before we discovered electrons, we discovered electricity. And so when electricity was first discovered, they thought it must go from positive to negative. So whenever we're talking about current, we are always talking about the current going from positive to negative. What that means is that if you have a battery like this, nothing will happen, because you've got the two negative ends touching each other and the two positive ends opposite each other. And so this battery is trying to make electrons flow one way, and this battery is trying to make electrons flow the opposite way, so they cancel each other out. So a battery is more than one cell. So that is a battery, that is a cell. Okay, and remember, the long one is the positive, and the current goes from positive to negative. The other circuit symbols that you need to know is a switch, which you can draw like that. Okay, a switch is something that just opens the circuit to turn something off, or closes it to turn it on. That's a switch. You need to know what a resistor is. You need to know what a variable resistor is. Now, a variable resistor is a component where you can change the resistance. And so a variable resistor looks like this, and the arrow going across it means that you can change the resistance. So that is a variable resistor. You also need to know what an LDR looks like. Now, an LDR is a light-dependent resistor, and they look like this, and they change the resistance based on the amount of light that is coming in. So very bright lights has a different amount of resistance than very dim lights, and we'll learn about that next time. So that's an LDR. A thermistor has the same kind of idea, except instead of light, it's temperature that it's dependent on. So the hotter it is, the temperature of the room that it's in changes the resistance, and they look like that with a line and then a little arrow. So you can see they've all got this basic resistor shape, but then a slight variation on that. So that's a thermistor. A bulb is just a simple X in a circle like that. That's a bulb. We already talked about a voltmeter and an ammeter in the last video. That one measures the potential difference, and that one measures the current. You also need to know about a fuse. Now, a fuse is a safety device we'll talk about in a different video, but they look like that. You also need to know what the symbol for a bell is, so something that makes a ringing sound. It looks like a backwards capital D with two wires coming into the curved part. You need to also know what a diode looks like. Now, a diode is something that only lets electricity flow in one direction. And a diode looks like that, sometimes with and sometimes without that circle. And similar to that is an LED, which is a light emitting diode, which is exactly like a diode except it gives off light, and these two arrows represent light. You've probably heard of LEDs before. You can also have a coil of wire. Now, a coil of wire is useful in transformers, which change the amount of voltage and current. So you've got a coil, and then you can have a transformer, which looks like that. And that is two coils next to each other. All of these should be either available in your textbook, in your booklets, or on the internet on websites like GCSE Bitesize if you need something to print them off fully. Now, there are two ways that we can arrange our circuit. If we have two bulbs, we can either connect them like this, or we can connect them like this. Both of them are making full circuits with the battery for both bulbs, but they're connected in different ways. Now, we call this one parallel. Now, an easy way to remember that is that these two bulbs, the wires connecting these two bulbs, are parallel to each other. This one is connected in series, and you can remember that one because in a TV series you watch one episode, then the next one, and they don't make much sense if you watch them in the wrong order. And in here, the current is flowing through one, and then the other one, and then it goes back. So this is connected in series, this is connected in parallel. Now, the first thing that you can see from that is that if one of these bulbs breaks, let's say, for example, this bulb breaks and this bulb breaks, then in the parallel circuit, the other one is going to stay on. There is still a complete circuit there, so this bulb will stay on. It will not be turned off if one of the bulbs breaks. This one, however, if this bulb breaks, it creates a break in a circuit, and there is no way that those electrons can flow all the way around the circuit. So now all of these bulbs will switch off in series, but in parallel only the broken one switches off. That's the first thing. The second thing is how we measure current and voltage in series and parallel circuits. Now, you remember that current is the flow of electrons, and electrons can't be in two places at once. So if electrons are flowing around this circuit here, current is flowing around this circuit here, then when they get to here, the electrons have two choices. They can either go this way, or they can go this way. And so the current is split between the two bulbs here. Here, the current, the electrons, and so the current have to go, they've only got one way to go. They have to go all the way around this way. So however many electrons are coming through this one also have to flow through this one. So here, all of this one has the same current. So the current is at maximum all the way around. Here, it's split into two, but here, the current is the same all the way around. Now, the opposite is true of voltage, and that's a little bit more difficult to understand. So if you imagine our ball rolling down the hill example, at the top, so at the battery, the ball has X amount of potential energy, and at the bottom, it has 0 potential energy. Then if you transfer this example to our battery, this is as they come out of the battery, and this is as it comes back into the battery, the electrons. So in your parallel circuit, it comes out of the battery. When it gets to this bulb, then it loses all of that energy, it goes down the whole hill, and then it comes back to the bulb. It comes back to the battery. Same with this bulb, maximum, minimum. Here, however, it's got to pass through two different components. So it leaves the battery, drops off some of the energy, but then also needs some more energy here. So gives some energy here, gives some energy here, and then goes back. So on this one, the voltage must be split between the two, whereas here, the voltage is at maximum for each of these components, because that is the total voltage of the battery, that is the total voltage of the battery, and that is the total voltage of the battery. But here, if you're just looking at one bulb, that is only half. So the key thing to remember about that is that in a parallel circuit, the current is split between the two components. In a series circuit, the current is maximum all the way through both of the components. In a parallel circuit, the voltage is at maximum across each of the components, and here in the series circuit, the voltage is split between the two components. Now, if we go back to our bulbs example, you can see that the voltage, which remember is the energy of the electrons, it's the amount of energy that we're giving to them. The voltage here is at maximum for each of these bulbs, so these bulbs will be brighter than these bulbs because these guys have to share that energy, but these guys have a maximum amount of energy. So these bulbs will be brighter and these bulbs will be less bright, and if you add more bulbs to the series circuit, they will get less and less and less bright. But if you add more bulbs to the parallel circuit, they will all stay at maximum brightness. Now for this last example, I'm going to swap bulbs for resistors. So I'm going to have the same circuits, but I'm going to swap bulbs for resistors. Okay, in this parallel circuit, let's say this is R1 and this is R2, and here we've got R1 and R2. In the parallel circuit, we can calculate the total amount of resistance of the circuit. The equation that we use for that is 1 over RT, where RT is the total, is 1 over R1 plus 1 over R2. Now in a series circuit, it's easier because the total resistance, these electrons have to go through both of these components, so the total resistance is just these two added together. So R total is R1 plus R2. So if you're ever asked to calculate the resistance of something, you can use either one of these two equations depending on whether you've got a parallel or a series circuit. And those two equations are used to calculate the resistance of each component, or the total resistance, if that's what you're asked for.